What's up, everybody? I believe we are live. Just waiting for you guys to show up and populate the chat. What's up, everybody? I believe we are live. Just waiting for you guys to show up. See who our first commenter is. Cole with the win. Sorry, Justin. What's up, buddy? Zane, not first today, eh? Kayla E. Robles, what's up, everybody? Unit 4. Hey, Brock. K-Ron. Anybody had a chance to go to the school and get their stuff this week? I think it started today. I don't know. You all had to sign up for a time. What's up, Addison? Anybody had a chance to go to school yet? Anybody go outside? It is hot outside. My daughter is currently running through the sprinkler just outside the window right there. So maybe she'll distract me, but I can't see her at this point. Karan is asking in the chat, where is the unit binder? Oh, man. Good question, Karan. Carly, what up, girl? Brooke says my parents didn't get an email. Oh, Brooke, then you definitely want to contact the office, okay, and arrange something, okay? Or if maybe one of Brooke's friends, if you'd be such a nice friend to forward her that email, because that's important. There's a very short window that you're able to actually go into the school and get your stuff, okay? So make sure that happens. Aris is in the house. What's up, Aris? Look at the slides. We got ourselves a new color scheme. Ooh, we got gold on blue for our water systems unit. Yeah, we do. Okay, so we are waiting. What's up, Gem BT Gaming? We are waiting for people to join us. While we wait, you are going to go to the Google Classroom, classroom.google, and you are going to find the water systems unit binder. You need to grab that. Let me just make sure that everybody has access to it. Okay. Kayla Robles says it's short. Yes, it is, Robles. This is the shortest of the units. That's it. Look how short this unit is. It's a itty bitty unit. Now, I always leave this unit to the end because we usually will go outside and we'll go walk to a creek or something, and we'll collect water samples, and we'll have a ton of fun. Unfortunately, can't do it. Can't do it. So, yeah. We'll find other ways. We'll talk about other ways that you can maybe have some fun in this unit. Let me know in the chat when you have the unit binder from the Google Classroom. Where is my mouse? Okay. Make sure you have it opened up and ready to go. Okay. Let me know in the chat. Say done. First one to say done and actually be done gets Marcus's bonus marks because he's not here yet. So let's see who's going to be the first. I think Kayla Robles already sees it because she knew it was short. I would say this is a fun unit. It's not a difficult unit, not a crazy unit. I had the most fun first lesson prepared for you guys. Another teacher gave it to me, and I was so excited about it all year long. I prepped it 2 months ago. Like, I was ready to go. It was super fun. But unfortunately, we're not in the classroom. So this is definitely is a very experiential lesson. Wow, here we go. Kayla Robles is the first one done for the question mark. So maybe she is, maybe she's not. She's leaving us as a mystery. Carly's second, Aris third, Addison fourth, Karan is fifth, Skip Zane, and Tatanaya is after. I forgot what number I was at. All right. So it looks like people have got their unit binder ready to go. Okay. As you can see above this shoulder, it is a short unit. Okay. I wasn't even planning to do the culminating task even in the classroom. I was going to be doing some fun STEM stuff. So Karan says he was first. Karan, I don't think you were first. You were like 90th in line. Okay, so I think this lesson or this unit is just more interesting. We're looking in depth at how the city of Ajax actually takes water from the Lake Ontario, and how they purify it and make it that you can drink and pee in it, and then how they take that and recycle it. So I think it's super, super important. So before I start, for people that are just joining us, like Marcus, I know I saw my numbers went up just a little bit, so there's a couple new people. You are going to the Google Classroom and you're getting the new unit binder, Unit 4, Water Systems. Okay, and you'll see that it is a short unit. Okay, we'll have some fun. And I could just give you unnecessary work once we finish this. Don't worry. Karan, I can load you. Zane, I know you want extra work, so I'll just think of some extra work if we finish early. So, all right, who's ready to learn? Karan says check again. I'm checking again, Karan. Yeah, Karan, you're way after Robles, Carly, Aris, Addy, and yeah, you're not first. You were the first to ask about it, Karan. You get credit for that. Aiden says we make a copy. Yep. Oh no. No, just use the original one. Actually, honestly, at this point, we've been out of the classroom so long, I don't even remember what it looks like from your end. Marcus is ready to learn. Extra marks for Marcus. Shout out to Marcus. I am running out of extra marks. He is just taking all of them. So, alrighty. For those of you that are playing along at home, this is what the unit binder looks like. Oh no, I forgot to add the slide notes. I did. I forgot to add the slide notes. So here's what I will tell you you should do. Okay, my apologies. It is Tatanaya's fault. I would go to your fluids unit binder. I would open your fluids unit binder. Man, looks like we haven't seen that in forever. I would copy this slide and I would paste it in here. And then I would paste it in here. And I will paste it in here. Okay, so I would do that if I was you, especially you guys that like to take notes and keep it in your binder. That is my fault. I forgot it. So My apologies. Okay? So we are going to be doing lesson 1, the water cycle. Okay? So let's move to that. Okay? Some of this I will touch on this during the lesson. So kind of flip back and forth between taking notes and seeing if you can answer any of these questions while I talk. Okay? You will notice that the lesson is entitled The Water Cycle. And I believe that many of you are quite familiar with the water cycle. Now, I'm not going to be teaching the water cycle in huge in depth because I know that you know the water cycle. Okay? So, we're going to be talking about other things. Once I find my mouse. Has anybody seen my mouse? There it is. Okay. This is very important. Water is clear. Water is colorless. Water is tasteless. And water is odorless. Okay? All of these things are required for it to be water. Okay? Boom. Hopefully you don't have to go to the bathroom because that might have not helped. Okay? So as we look at water, I am not blowing your mind. This is nothing crazy that I'm teaching you. All right? So water is clear. You have to be able to see through water. Okay? Water is colorless. It does not have a color. Okay? If we add, watercolor, okay, it has changed in some form. It is not pure water. Okay? It is tasteless. Okay? It does not taste like chicken. It does not taste like juice. Okay? You don't have those sugars in there. Okay? It is odorless. Okay? If you waft it, it smells like nothing. Okay? Today we were riding by a conservation area with lots of water. Okay? It stank. Okay? So that tells me it's not pure water in there. Okay? There's stuff happening. Okay? And of course, there's lots of microbes and everything that are living in there. Okay? So water at its purest form, it looks like this. Okay? Now, if we were to really zoom in here and look at it under a microscope, you might be able to say, MrStav, it is not perfect, and you're right. Okay, water we consume is actually not perfect, and we're going to learn about that. I'm going to take a timeout because I see people are asking things in the chat. Oh, Nathaniel showed up. That's good. Zane says you can't edit the original one. Oh, okay. So you guys are saying you have to make a copy. All right. Do I need to repost the unit binder? Let me know, chat. Do I need to repost it? Did I do it wrong? Aiden, let me know if I did it wrong. Zane, you can't edit it at all? Let me know. Okay. What happened to my water? Okay. Is this water? According to the definition, it is not. All you people are saying yes. You're saying yes, I need to repost it? Okay. I'm going to pause the lesson because this is important. And I'm going to okay. How about I just delete this? Okay, it's gone. Create an assignment. Google Drive. Do your thing. I know what I did. I put materials last time. Make a copy for each student. I didn't have that option. Final unit. No due date. Topic is science water systems. And let's assign it for everybody except for Aiden. I'm just kidding, Aiden. There we go. Assign. All right, folks. Do me a favor and delete that last one. If you opened it, delete it from your Google Drive. That way you guys don't get mixed up and messed up, and I don't get mixed up and messed up. Okay. Addison said hers was working. So the problem is if you guys make a copy, then it's not shared with me, so I can't creep on your work. So that's a problem. And Addison says then just share it with MrStav. Yeah, that would be good, but a lot of people forget to do that. And so when I do their marks, they get 0 because they're like not sharing it with me. All right, so go ahead and go to water systems. Not systems, water systems. Okay, they're different. Okay, and add that up. Okay. Okay, so most water, while you do that, most water that you encounter is not actually considered pure water. And by pure water, we mean clear, colorless, tasteless, odorless. Okay, so this is clearly not pure water. Okay, however, I'll tell you that we're going to learn in this unit that our tap water is not pure water. Okay, and when we say pure water, we mean it only contains water particles. Okay, the water that we consume that comes from Lake Ontario, that is purified, that is cleaned, and goes through a massive process that you're going to learn every step to in a fun way. It's going to be awesome. You'll love it. That water is not pure water. Okay, we actually intentionally add things to this, things that are for cleansing, things that are actually to help our bodies, okay, and things that are keeping bacteria out. Okay, so this is not pure water on a scientific level. Okay, get my mouse back. Okay, how about this stuff? Definitely not pure water, right? Tons of sugar and other stuff in here. When we say pure water, we are talking at a grade 9 science level. H2O, and you've heard this tons, okay? But what does H2O actually mean? Tell me, chat, what does H2O mean? What is this? What is this? And what does this mean? Tell me, chat. Looking in the chat, Brooke says, now the unit binder is good to go. Thanks, Brooke. Thanks for letting me know that. Super helpful when you guys keep me up to date. Keep me in check. Appreciate that. That's why I love this live format. All right, what does H2O actually mean? Aiden swoops in for the win. Remember, if Aiden answers, doesn't mean you don't have to answer. Okay, throw me all your answers. H stands for hydrogen, and O stands for, according to Maher, oxygen. Maybe a typo. Oxygen, he says. Okay, so what does the 2 mean? So the 2 is an indicator. Blue. The 2 indicates that there's actually 2 H's. Okay? So we could actually write it like this. There's an H, there's an H, and there's an O. Okay? 1 O. Okay? We don't need to write the 1. Okay? And 2. If there's a 3, then we would add another H. Okay? Now looking over here, oh, there. Okay. This is what on a scientific, very, very zoomed in microscopic level. Okay? This red is an oxygen particle. Okay? And these 2 white ones are the H's. Okay, so this would be a single water particle. Over here, this is a second water particle. Okay, and here's a third one. In high school, you're going to create a bunch of these for a number of different substances. You're going to learn the chemical compounds, the codes, everything. You're going to learn all that. Okay, you're going to learn how they change, and grade 9 science is pretty cool. It takes this to like a super awesome fun level. Okay, so when we say that water that you consume, although it looks pure and it looks perfect, okay, this is not pure water. Okay, this is not just these red and white things. There's H2O. There's more compounds, there's no more particles in there than just this H2O floating around. Okay? So there's the animation of that. Okay, again, these slides will be available to you on MrStav.ca/science. Okay? Boom. Water is found naturally as a solid. It can also be found as a liquid, and it can be found as a gas. I think you know this. I think you've heard this said many, many times. Okay? And let me know in the chat. What are the forms of water as a solid? How does water appear as a solid? How does water appear as a liquid? And how does water appear as a gas? Okay, let me know in the chat. Okay. Now this slide, I don't think you need to copy this down. This is what we've been talking about all year long, right? So solids, particles are vibrating, but they're so tightly packed that they don't really move much. Okay. So then they say a lattice frame here. So they're arranged in lattice framework. It means they're very tightly organized. Okay. And they're relatively far apart. Okay, so here we go in the chat. Kayla is saying that in a solid form, okay, water appears as ice. Oh, Marcus also saying ice. Kurt saying ice. Marcus saying what Kurt said. And there's Janae. Janae in with ice. All right. So, in water, okay, the particles look like this lattice framework, okay, and we'll move on. Okay. So solid water is less dense than liquid water. So we talked about ice being solid, okay, so it's actually less dense than water in its liquid form, okay, and its liquid form would be water. Okay, so who said water? Kayla said, Kurt said, Janae said, and Marcus said what Kurt said, so thus Marcus said. Okay, that's probably an important feature to know, is that water is less dense in its solid form. Okay, so ice is actually less dense than water. You ever think back to our last unit when we talked about density. Have you ever put an ice cube in water floats. Why? Because it's density, right? Just like we talked about and we did that experiment, things that have a lower density, boom. Who says you don't learn in science? Nobody said say that. That's not true. Okay. Boom, there it is. This means that ice floats. Okay? That's why ice floats in your drink. It does not sink. Okay, liquid. In a liquid, you know this, particles are moving faster, but they are actually able to move freely. Okay? So here's kind of a better look at what I was saying, this diagram. So in its solid form of ice, okay, they kind of range up. See how these are those red and white things, the H2Os? Okay? See how they link up in a nice kind of organized fashion, hence the being less dense, right? Density is how much space that they're taking up. Well, they're not taking up as much space. Look how densely packed water is. Okay, so water in its liquid form is much more dense. Okay, and then in its gas form, what did you guys say for gas form? Kurt said steam. Janae said steam. Robles said vapor. Marcus said what Kurt said. So yeah, steam, water vapor, clouds. Okay, these are all. This is what it looks like. Look at the space in between. Okay, this is why gas is so thin, right? It's not dense at all. It's very, very low density. That's probably not a good sentence there. Now, all right, we'll come back to that. Okay, so gas, the particles are moving very fast, and they move in all directions. Oh, there you go. There's a better term. Okay, so if you are following along, skip to question 3. Okay, you need to fill in the blanks here. Okay, and you're going to use this slide. Okay, so to go from a solid of ice, okay, melting has to occur to become a liquid. Okay, to go from a liquid to a gas, evaporation has to occur. Okay, I think that you guys are pretty good with knowing that. Okay, now the other way is probably a little bit trickier. Okay, and so to go from gas to a water or to the liquid, we have condensation. Okay, so fill that right in, condensation. Okay, and then you know this, to go from a liquid to a solid or to ice, freezing must occur. Okay. So these big ones, here we are removing energy, and up here we are adding energy. Okay. Checking the chat, see if anybody has any questions. Looks like we're good to go. Okay. Now this is easily Googleable. Googleable? Made that up. I'm sure I'm not the first person to make that up. Okay, but it's also going to be in the notes at MrStav.ca/science, or you can pause the video and come back to it. So don't yell at your computer, "Stop, MrStav, slow down," or say it again. You can literally make me say it as many times as you want. All right, you can make me repeat myself as many times as you want without me getting upset. Okay. Kind of looking back. Okay. Question 2. This is a bit of more of opinion. This is going to be less Googleable. Okay, but think about what we just talked about. How ice is less dense than water. And so that means that ice floats. And I was using the whole drink analogy. But don't just think about our drinks. Think about our ecosystem. Think about how important it is in the northern area for ice to float. Okay, what's happening as we lose these ice chunks, okay? But maybe you can think of other things, okay? So the question is, why is it so important that solid water is less dense than liquid water? Consider the implications for your ecosystem if solid water was more dense than liquid water. What would happen if all those icebergs sank and we're at the bottom of our oceans? Okay, what would that mean for the things at the bottom of the ocean? Okay. So you can answer question 3. You can answer question 2. And question 1, you absolutely can answer. And we are good. So let's move on. I think I left the slide up pretty long for you. Okay, so water changes states through the addition and the removal of heat energy. Okay, and that was these big red arrows. Okay, boom. Okay, when we add heat, okay, or we remove heat or remove energy. Okay, I'd rather use that term. Okay, heat energy affects the movement of the particles. More heat, we move faster. Less heat, we move slower. Okay? Here's some other terms. Heat absorbed versus heat released. Okay? I'm not probably going to, I don't want to say this because I can't remember right now the test. I should go study it. But these terms, be familiar with. Okay? You know condensation, you know evaporation, okay, solidification, okay, melting or freezing, okay. Oh, I know what I did. I know what I did. Okay. Change what I said. Let's go back to this. I know what I did. Okay. So we filled these ones in and we put energy here. I would maybe move that text box down here and I would put in here, going from a gas to a solid would be deposition. Okay. And mouse, where are you? Up here, make that sublimation. Okay, so fix that. These ones were good, and I would still keep the adding and removing energy. Okay, but make sure that you have sublimation and deposition in here. Okay, I apologize. Again, Tess and I's fault, not mine. All right, let's talk about the water cycle. You know about the water cycle. The water cycle is how we reuse water, okay, through the states of matter. Okay, so water is constantly moving around the earth, and you know this. We call this movement the water cycle. But take note of this, okay? Hydrologic. Ooh, big word. Okay. This is another term. This is a more scientific term for the water cycle. Should I put a question on the test? And instead of calling it the water cycle, I call it the hydrologic system cycle. I need to go and play the sprinkler. Okay. If I call it that, you should be familiar enough to know that I'm talking about the water cycle. Got it in the chat? I like when you guys say got it. Lets me know you're listening. These are just cool diagrams that I found. It was like an awesome way of representing. Okay. So here's some of the keywords that we just kind of put into this diagram. We have evaporation, right? From evaporation, we have condensation, right? So it turns into a gas, and then it turns into a liquid and it rains down. Okay? Now, I don't remember how many of you remember, I don't know how many of you remember grade 4, but any of you, let me know in the chat, do you remember going to the Groundwater Festival? Yes, Kurt. Kurt, first one to say got it in the chat. How many of you remember going to the Groundwater Festival? And this is a grade 4 only trip, and it's annual. Every year the grade 4s get to go. Probably not going this year. Sorry, grade 4s. But super neat. You get to see this groundwater experiments, hands-on learning. I got to go one year, even though I've never taught grade 4, but I got to be the male teacher on this trip, and it was actually super neat. And at the very end, you get to see salmon swimming upstream and then jumping up this waterfall. I don't know. Kayla, you don't remember this? I'm sorry. Hopefully someone remembers going onto this trip. Kurt, you didn't go? Carly, you didn't go? Ooh, this is such a cool trip. I gotta ask the grade 4 teachers. Ours, you didn't go? Ooh, you guys got. Sorry. So every year you learn similar systems, or the units are very similar, right? So you do learn about water every year in science. So this grade 4, you really specialize on the groundwater. So I'm so super bummed you guys didn't get to go. Awesome. So let's look at this a little bit more detail, right? So when it rains, it pours. No. So when it rains, right, water will run off of mountains, hills, you know this, okay, off of trees, okay, and will run into streams, streams then run into lakes, lakes run into oceans, right? So then the water then evaporates, okay? But what we also take for granted is that water also goes into the ground. Chat is just filling up with you guys saying that you don't remember this. That just breaks my heart. Okay? So when you see water streaming, that makes sense. But actually, what you're not seeing is this groundwater system, which is phenomenal. Okay? So water goes down into the grass or into the dirt, and it just keeps going further and further down. And now some of you, think about this. I'm sure most of you, you've at some point gone to a beach, and instead of going into the water, you dug a hole. And you dug a hole, and you dug a hole, and you dug a hole until you hit water. Yes? And that's when you ever celebrate. It's like, yeah, we hit water. And what you're doing is you're digging into that groundwater area, right? So even on a beach, the rain is going down into the sand. Some of it runs into the water, but some of it goes into that groundwater runoff. So we're more onto this slide if you're kind of wanting to follow along. Okay. So any water that infiltrates is an awesome word, right? Which goes through, right? So you can infiltrate prison, and you can infiltrate a security system. You can break in, right? So water that breaks through that ground, okay, it goes down. We call that groundwater. Now, I don't know who thought of that name, but that's brilliant. That is excellent naming. Groundwater. Any water that goes into the ground. Amazing. Who named that? Marcus, you couldn't have named that any better. Just looking at the chat, Zane is asking what happened to the fish in our class. The fish in our class were rescued. They were taken out, and they were taken back to the main study or the lab that the group that I signed up with. They took them there, and they were able to harvest 86 out of the 100 eggs. So normally I would be like pretty sad about that, that only 86 made it. I think last year we lost about 4 fish. Okay, but at one point we thought all the fish were dead, and we were pretty sad, and then we were super excited when we saw some alive. And so a total of 86 of our fish made it. And I don't know if I'll send an email, Zane, but they will be, if they have not already, been released into a proper wild stream where they will survive and they will grow. So yeah, good question. Our fish, 86 out of 100 are good to go and are healthy and living. So that's almost enough. I think that's enough. We could name each one after all of the grade 8s. Let's do that. I'll call him up. His name's Ben. I'll say, Ben, name him after my grade 8s. So yes, Brooke says yay in the chat. Yay for our fish. So 86 out of 100, not normally a good stat, but given these conditions, that they were not able to be cared for like we would normally do, very happy for them. And for those of you that don't know, we literally had to monitor the temperature in the fish tank every day, and then Miss Marqueux and I would make adjustments after school. So I've been to the school 2 times since March 13th. So not ideal scenario for these fish, and we're just grateful that the fish tank, the freezer, and everything that refrigerated that water and kept it at the right temperature held up, and 86 made it. So that's awesome. Yes, I do feel sad for the other 14 RS, but very happy for the 86 that overcame the odds. So back to what we were talking about, groundwater. All right, anything that goes into the ground. Awesome name. Okay, so this is seeping through soil, through rocks. Okay, they just make their way. Okay, the surface of the groundwater is called the water table. Okay, we'll see a diagram of that. Okay, but you need to be familiar with these terms. You need to be familiar with the word groundwater. You need to be familiar with the word water table. Okay, the surface of the groundwater is called the water table. Okay, this is the depth at which soil or rock is completely saturated with water. Okay, so coming over here, let's change my pointer options, or let's just get rid of this. You could come up here and water will be in here, but it won't be like soaking wet. Think of like a towel that's never been touched, and then you use it for a shower. Okay, then it's wet. Okay, but if someone's pulling a mean prank, they throw your towel in the pool or in a bathtub. Okay, and you pull it out, that is saturated. That is soaking wet. Okay, you are not going to dry yourself with that. Okay, so the surface of the groundwater, is called the water table, and that's where the dirt is just saturated with water. It is soaking wet. Okay, so here's a different look. Okay, if we were to cut a city, okay, this little countryside. Okay, so you see we've got a farm over here. Right, lots of soil. Right, where the rain goes into the crops, they take what they need, and then the water comes down. Right, so you can see at some point here, this is where the dirt has become saturated with water. Let me know in the chat what you think this thing is. You see one here and you see one here. What do you think those are? Come on, chat. Let me know. Let me know. What do you think those are? So we have a farm here, and this is cutting the middle of the farm so that we could see a cross section is what we call, right? You'll notice that where the body of water is, look under here, this is the ground. This will be the bottom of the little pond or the lake. Okay? It looks just like over here. Okay, not a coincidence. Here we go. Chat is coming in. Meher says water level, maybe. Okay, so maybe it's like a kind of something that the graphic artist put in. Kurt says water collectors. You are very close, Kurt. You are very close. Brooke says, and I love that. That's okay. It is okay not to know. If you know all these answers, then I don't have a job. Aiden and Justin, for the win, say a well. Yes, a well. Okay, these are wells. Now, if you've ever heard somebody from a countryside say we don't have water pipes, we go to a well. Okay, or if you watch Survivor and they go to a well, okay, or back in the day you hear about wells. All right, our wells look very different than they did back in the day, right? So back in the day, the big circular brick, right? And someone would have a bucket, and they get some water. Okay, our wells look a lot different these days. They're a lot more technologically savvy. Okay, but what a well is a hole that is drilled through the dirt, through the ground, through the soil, and then they put up walls to protect it so that none of the dirt goes in. Okay, and it passes beyond the water table and goes deep into that groundwater. And so what farmers or people who don't live close to a water, like a city that has pipes everywhere, okay? Oh, my trackpad is doing it again. Okay, off the grid at cottages maybe, they will dig a well, drill a well. These are deep, Okay, so you're not gonna like stick your hand in there. And you hear about like kids that fall in a well. Okay, like these are deep, deep tunnels. Okay, vertical tunnels. Okay, they go past the water table and down here, and so they can collect the water and then bring it up for consumption. Awesome job, Aiden. Awesome job, Justin. I remember when I first looked at this image, I was like, I had no idea what that is. So, yes. So we can access groundwater by drilling wells. Okay? All right, so notice, okay? So we are on question 6. Okay, question 6. All right. Groundwater can create an, that's a big word. Aquifer, Aqui. You know, we need a strategy when we don't know how to pronounce a word. How about this? YouTube.com. Pronounce aquifer. There we go. I hope you guys can hear it. Let me know,
Aquifer.
let me know in the chat if you can hear it.
Aquifer.
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 All right. So there you go. You can learn how to say words that you don't understand, you don't recognize, just like that. Okay. Aquifer. This is a geological formation of loose rock or soil that is saturated with groundwater. Okay. So looking here, we have a confined aquifer. Meher says that's loud. My bad, buddy. All right, we have a confined aquifer, and then we also have unconfined. Okay, so what are the two types of aquifers? Aquifer. Kind of sounds like you're used to the word aqua, meaning water. Aquifer. Here's our water table. Okay, So aquifers can be unconfined. Okay, so they're topped with permeable layers. What does permeable mean? Like the ability to pass through. Oh, we talked about that. Remember cells, right? So you have permeable, semi-permeable. Okay, semi-permeable means it lets some things through, but not all things. Okay, and confined means impermeable. You cannot pass through. Things cannot pass through. Okay. So looking here, we have a confined layer or a confined aquifer, which means it is impermeable. Whereas here, we have an unconfined, which means it is permeable. Things can pass through. Okay? Get that in there. What is the difference between them? I literally just covered that. So by now, you should be able to answer all of the parts of this lesson. Okay? So, I think it's been long enough. Yeah, it's been too long. 50 minutes. You guys need to go play in sprinklers. So, we're going to leave it there. No, don't keep my drawings. Okay? At the end of this lesson, you should be able to answer these 2 slides. Okay? There you go. These should all be completely filled out. Some you should be able to fill out using my lesson, and some you should be able to fill out using your thinking and thinking beyond. Okay? The next lesson, we're talking about water treatment. Whoo, boy, I love this lesson. Okay? It is so interesting to me. We are going to look at where Ajax gets its water from, okay, and how it cleans it. Okay? We're going to look at how we deal with our water waste. We're going to look at step by step. This will probably take Friday and next Wednesday. Okay? I had tried to get us a field trip to actually go to the water treatment plant where Ajax deals with this. It was booked, and then they changed their policies because I think students who from other schools that went were interrupting the water purification process. So that's okay. We wouldn't have been able to go anyway. So okay, welcome to Unit 4, our final unit. It's crazy because it's so short. We're almost done it already. Okay, so we talked about the water cycle, talked about groundwater, talked about aquifers. Okay, big words. Okay, we talked about how neither of these is pure water, even though this looks like pure water. Okay, it's drinkable water, but it's not pure water. This is not pure and it's not drinkable. Okay, this has water in it, but it's not pure water. Okay, so I hope you guys had fun. Hope you enjoyed that lesson. We're gonna get some pose coming up. Let me go look at my my unit plan. What I would like you to do in the meantime is I would like you to ask your parents if you guys have a pool, then this would be sick. If you don't have a pool, like me, okay, but you have a friend, you know someone who has a pool, okay, see if you can borrow 6, 7, 8 pH strips, okay? This will be for lessons down the road. Okay, and pH strips are used for a lot of things. Okay, and I have a bunch in the classroom that I bought for you guys. Okay, they kind of look like this. Mine actually look simpler. Some are blue. Okay, mine look like these. Okay, if you can get 6 or 7 of those, we'll do some experiments and you can actually play along at home. It'll be super fun. Okay, I'll give you a little bit. This is what mine looked like. Mine looks like a matchbook. This is exactly what it looks like. And so I rip them out, and I give each of you guys 6 or 7, and we actually get to test water, and we get to. It was crazy. Last year, we did a test on one of our. You know how like there's old. See, at our school we only have new stuff. At my old school, there's this like the new water fountains, but there's also this nasty old water fountain that worked, but it was like dirty, nasty water. And so the kids actually tested that water and found out some cool stuff. So kids brought water from home, from their taps, from their pools. So we'll do all of that later in this unit. But in the meantime, start asking around, see if you can find any friends who have pH strips, okay? And ask them if you can have 6 or 7. pH strips are very, very inexpensive. I got 2 of these matchbooks for like $6, I think, off of Amazon. But I just don't know if they would come to you in time if you wanted to order them, and you don't need a whole mass of these. Okay, so that's what's coming up. We're gonna be testing quality of water. We're gonna be learning how to purify water, and I'm gonna see if we can actually have you make water purifiers at home. Okay, so normally in the classroom, we would take this water, and in the class, in our science lab, we would have made it look like this. We would have poured it in a water purifier that you made, and then only Marcus would have been allowed to drink it for bonus marks. Just kidding. Never consume any science projects. All right? So that is lesson 1, and that is kind of a look forward. Do you guys have any questions? If not, start saying goodbye to me in the chat because I love when you say bye. Thanks for joining me. Go outside, play in the sun. It is beautiful. It is hot. And I do have guided right now. At 2 o'clock is guided. Normally, I save it for my math help. However, I will open it up to anybody who wants to ask questions about the science test. So Miss Vigilaratnam's class, if you would like to join us, go to bit.ly/STAV online guided, and you can come and we can talk about the unit test. You can ask me questions. We can kind of try to answer some of the harder questions and figure out where you went wrong. Well, here we go. Everybody's saying bye. Bye, Aris. Bye, Robles. Bye, Aris again. I'm just saying bye a lot. Addison. Later, Kurt. Aris is saying bye again. Okay. He really wants to say bye. Mayor, later. Carly, see ya. Stop saying bye, Aris. Brooke, bye. T, see you later. Aiden, peace out, brother. Later, Marcus. Josie. Peace out, homies.